Welcome to the deep dive. So just take a second and think about the clothes you're actually wearing right now. Could be your jeans, maybe workout gear, maybe even the pajamas you put your kids in last night. We kind of expect them to fit, right?
Yeah.
To perform, and maybe most importantly, be safe. But have you ever stopped to think about the blueprint behind making them? The invisible instructions. What happens when those instructions, when they actually go wrong? Today, we're going to pull back the curtain on something called the tech pack in the apparel world. And look, this isn't just some, boring internal document. Not at all. A tech pack is basically the master blueprint. It's incredibly detailed. It tells the factory everything, what fabric to use, exactly how to stitch it, how to dye it, the finish, everything. And here's the kicker. When these tech packs are, well, deficient or incomplete or just badly managed, the results can be, frankly, catastrophic. We're talking huge product failures, multi-million-dollar recalls you read about in the news, and serious lasting damage to a brand's name. So our mission here today on this deep dive is to unpack 11 real-world examples. And these are from some really good names in fashion and sports. You'll recognize them. We want to see exactly how these failures happened, what the cost was, and really crucially, what lessons were learned. Lessons that are now being built into better tech packs to stop these things happening again. Get ready for some, I think, pretty surprising facts and maybe some aha moments about the clothes you wear every day.
Yeah, it's a great topic. And what's really fascinating, I think, is just how critical these documents you don't even see are. They're critical to the product's integrity, right? And ultimately to public safety. And of course, the brand's reputation. It just shows that even for something seemingly simple, like a t-shirt, the devil is absolutely in those details. If that blueprint, that tech pack, isn't precise and comprehensive, well, the whole thing can just unravel fast, including consumer trust.
Okay, let's dive right in then. First up, let's look at challenges around the basics, materials and specifications. These are cases where maybe small errors in the fabric itself or even just the labeling cause massive headaches and huge financial losses. And the first one, I bet a lot of you remember this, Lululemon's invisible pants. Back in 2013, the problem was, well, pretty straightforward but devastating for them. A lot of their popular Luon yoga pants, they were just too sheer, see-through, basically. Turned out the fabric was made about 20% lighter than what was specified in the tech pack. And this wasn't just a little oops. It led to a huge wave of complaints, an estimated $60 million recall. Their product director even resigned over it. So beyond just check the fabric weight, what's the deeper lesson here? How do brands stop that kind of fundamental error?
That's a really good question. It gets right to the core of tech pack diligence, doesn't it? The real insight isn't just listing a minimum GSM that's grams per square meter, the fabric weight measure. It's actually about embedding specific verification methods right into the tech pack itself. So for Lululemon, the lesson was, you've got to clearly spell out how pilot batches get tested for transparency before you go into mass production. You need to specify who does the test, using what method, and define the acceptable range for the results. It pushes it beyond just writing down a number. It becomes a proactive control step, making sure what you want is what you actually get.
Right. It's about building in the checks. Makes sense. Okay, next example. More recent, this one. Patagonia, 2023-24, and an issue with UPF mislabeling. So they had these Capling Cool Daily and Tropic Comfort garments labeled UPF 50 plus flown, which is, supposed to be excellent sun protection. But then it came out that a lot of them only offered UPF between like 17 and 45, much lower. And the root cause, apparently their own internal labs used the wrong testing method. How does a big reputable brand like Patagonia get that wrong? What does it say about the fine print needed for these kinds of claims?
Yeah, this case really drives home why precision in documentation is just non-negotiable, especially for performance claims. It shows that for any regulatory or performance claim, like UPF 50 plus I, the tech pack has to be explicit. It's not just what to test for, it's the exact testing method that must be used. It's the specific accredited lab who has to do the test, and the precise acceptable results ranges. You can't just say test for UPF, you got to say test using this specific ISO standard by this certified lab, results must be between X and Y. Even a small deviation in how you test can totally invalidate the claim. And poof, there goes consumer trust.
Wow, okay. That level of detail is intense, but clearly vital. All right, let's shift from performance claims to absolute safety. And nothing's more critical than flammability, especially with kids' clothes. We've got two examples here that really hit this home. First, H&M Children's Pajamas 2019. The knit fabric just wasn't flame retardant enough. And when they looked at the tech pack, the lab test table was incomplete. Crucially, it didn't reference the required U.S. federal standards 16 CFR 1615-1616. Those are the specific rules for kids' sleepwear flammability. And then a similar issue, but older Gap children's pajamas in 1999. Their fabrics failed to self-extinguish. Why? because the spec for the flame retardant finish, it had actually been removed from the tech pack, apparently to cut costs, but the risk assessment wasn't updated. So, looking at both H&M and Gap, what's the systemic weakness here? How do these fundamental safety failures slip through?
That's off the million-dollar question, isn't it? It often comes down to a breakdown in communication between departments or a siloed approach to documentation. For H&M, the lesson was pretty stark. Tech packs for kids' sleepwear have to explicitly cite all the applicable legal standards, not just vaguely mention flammability. They need to mandate lot testing so every batch is checked, include precise fabric lot ID, define fiber blend tolerances for consistency. With Gap, that was maybe even more insidious, right? A cost-cutting decision removed a safety feature, but the risk profile wasn't revisited. The big lesson there is that any change to a finish, or really any material change at all, must trigger a new tech pack version. And it has to go through a formal design change approval. You need that holistic view. Who does this one small change affect everything else? Compliance isn't a one-time checkbox. It's about anticipating the domino effect.
That focus on fundamentals and really strict change control. Yeah, that makes a lot of sense. Okay, so we've talked fabric. Now let's move beyond the material itself. What about when the actual construction, or maybe design features, aren't properly checked? This is where it gets really interesting, I think. Shows how design flaws, overlooked safety bits, can trip up even the biggest names. Let's start with Nike. Remember their NBA jerseys back in 2017? You probably saw the headlines, brand new Nike Aeroswift jerseys ripping. At the seams, around the numbers. Sometimes right in the middle of the game. It was pretty embarrassing for Nike, obviously. Very visible. Experts pointed to issues with how the embellishments, the numbers, logos were applied, and the stitch density. That's stitches per inch, SPI. Apparently, the tech packs were missing clear tolerances for these in the sewing specs. The immediate fix, Nike had to reinforce the jerseys mid-season. So, okay, lesson one is obviously get your stitch density right. But what else gets missed in tech packs for high-performance athletic gear?
Right, this is where theory hits reality hard. Often, tech pack specs are written with, maybe, production efficiency in mind, not necessarily performance durability under extreme stress. A tech pack might say, use this stitch type, but it might not specify how that stitch needs to perform under repeated, aggressive stretching or high friction or sudden impacts, or even just how it holds up to sweat over time. The failure wasn't just about a number missing. It was about a lack of dynamic performance testing feeding back into the document. So every print, every application, it needs defined pull tests, sewing tests, with clear SPI thread tension parameters. And those tests need to mimic game conditions as much as possible. The tech pack has to truly reflect the performance demands,
Simulate the real world. Got it. Okay, speaking of performance, let's talk about Under Armour. Their Mach 39 speed skating suit, Sochi Olympics 2014, high stakes. The suit had this design feature, a back ventilation window. But athletes and analysts started saying it actually created drag. It slowed them down, and the critical mistake. This feature hadn't really been tested in competition conditions, not at those speeds, on the ice. The result, the U.S. team actually switched suits mid-Olympics. A huge blow for Under Armour. Very public failure. So what's the core message here about baking real-world validation into performance wear tech packs?
Oh, this case is such a powerful reminder. You have to validate design choices under actual operating conditions, period. The core message is that for performance wear, especially at that elite level, the tech pack must include records of real environment validation, aerodynamic tests. And this has to happen before the design is locked down. Certainly before you mass produce for something like the Olympics, you can run all the computer models you want. But if it hasn't been in a wind tunnel or on the ice with real athletes giving feedback, you're basically gambling. The tech pack shouldn't just be instructions for assembly. It needs to be like a living document that proves every feature works as intended without messing something else up.
Yeah, absolutely. Theory meets reality. And when we talk safety, nothing's more critical than baby clothes. Just a different level of scrutiny needed. We have two examples here that really hammer this home. Marks & Spencer recalled a baby fisherman coat sizes 0-6 months in 2025. Why? The final pattern didn't meet their own internal safety specs. There was a potential choking or fit risk that got missed. And similarly, Primark or Pennies, depending where you are, they were called faded leaf children's shorts in 2023. The waist cords were too long, over the 20-centimeter limit, a potential strangulation hazard. Turns out the tech pack didn't specify the free length according to the European standard EN 146A2. These details seem so tiny, but the risks are enormous. What's the absolute non-negotiable takeaway for child safety in tech packs?
It just underscores that you need an absolute, unwavering commitment to child safety standards built into the process. For M&S, it means ensuring every pattern review, every sample for those critical infant sizes is signed off against a detailed checklist, a checklist covering all relevant safety standards, within the tech pack. It's not just a general, looks okay. And for Primark, the lesson is about having mandatory fields in the tech pack for child safety specifics, drawstring length, toggles, small parts, and including photographic evidence with rulers in the picture, often in the POM section, points of measure. There's just zero room for assumption or oversight with kids stuff, none. The tech pack has to be like a fortress, proactively documenting every single safety detail against all the relevant standards. It can literally be life or death.
That really puts it in perspective. It raises this whole question about the product life cycle, doesn't it? From the first idea to someone actually wearing it, every single detail needs rigorous testing, documentation, thinking about potential misuse too.
Exactly. What really stands out is that a performance claim, like speed or a safety promise, especially for kids, it can only be guaranteed if you have both precise specs and that real-world validation locked down in the tech pack. It's not just about what you're making, it's about proving it will work and will be safe.
You're absolutely right. Okay, our final set of examples. These show that sometimes the problems aren't even obvious in the fabric or the stitching. Sometimes they're hidden in tiny details or even in the chemical makeup. These are the kinds of things that spark lawsuits, big public apologies. Let's start with Adidas. Remember the Columbia misprint? Copa America 2016? Yeah, this was a pretty big blunder, widely reported. A simple artwork error in the tech pack led to thousands of jerseys, even billboards, spelling Columbia, C-O-L-U-M-B-I-A, instead of C-O-L-O-M-B-I-A, just one letter, but culturally, nationally. A huge miss. Adidas had to issue a public apology. Never looks good, right?
No, never.
So how does something so, minor on the surface lead to such a PR disaster? What's the lesson about needing precision in all tech pack details?
It's such a classic case of the smallest detail becoming the biggest problem, isn't it? It just shows tech packs aren't only for the physical garment. They cover everything. Graphics, labels, text, all of it. The lesson is pretty clear. You need mandatory proofreading stages, robust approval processes, digital sign-offs, maybe even physical sample sign-offs like signed PDFs before any graphic goes to production. Brands usually have multiple checks for fabric, sure, but sometimes that final artwork approval gets rushed or overlooked. So you need a specific designated sign-off step for graphics and content, making sure what gets printed is exactly right every single time, because that reputational hit from a simple typo, it can be huge and expensive to fix.
Yeah, good reminder that text is a potential liability too. Okay, back to H&M. This time, a men's bracelet lead hazard 2023. An accessory recalled because it had too much lead, exceeding federal limits. The critical miss in the tech pack, the bill of materials, the BOM, basically the recipe list for the product. It omitted the finish on the clasp and didn't specify its exact metal composition. That small gap had big safety consequences. So why is the BOM so critical for chemical safety? What should it absolutely include?
The BOM is just foundational, not just for making the thing, but for compliance, for chemical safety. This H&M case shows exactly why. The lesson learned is crystal clear. All metal parts, actually, any component that could contain restricted substances must be explicitly listed in the BOM. That means their exact material composition, any coatings, any finishes, and the required heavy metal testing like EN 71.3, that European standard, or CPSIA in the US for lead. Without that level of detail in the BOM, you basically have a blind spot in your supply chain. No real way to guarantee compliance. It really boils down to knowing exactly what every single piece of your product is made of.
That's a scary thought. Unknown hazardous materials. Okay, finally, a really impactful case. Led to class action lawsuits. Victoria's Secret, formaldehyde in bras, back in 2008. The lawsuits alleged that a chemical additive, formaldehyde, caused rashes, even scarring for people wearing the bras. And this chemical, completely undocumented in the tech pack, invisible. How could something potentially dangerous like that just not be in the tech pack? What are the essential safeguards against these hidden chemical hazards?
Yeah, that's truly a nightmare scenario for everyone involved. It just powerfully underscores that tech packs must document all chemical finishes, dyes, treatments, everything. And it's not just about the stuff you know you're adding, it's about making sure your suppliers are totally transparent about everything they use in their processes too. Key safeguards. Mandatory Material Safety Data Sheets, MSDS. These detail a chemical's hazards, how to handle it safely. And crucially, brands need signed restricted substances list RSLs from their suppliers. An RSL is basically the brand saying, these chemicals are banned, these are limited, sign here confirming you comply. This case screams that if a chemical isn't explicitly documented and approved, you're opening yourself up to massive liability. Full transparency, signed agreements with suppliers, absolutely non-negotiable for health and for legal protection.
Okay, so pulling this all together, what does it all mean? I mean, this deep dive, looking at these real failures, it really shows that a tech pack isn't just some internal piece of paper. It's the invisible blueprint for safety, for quality, and, yeah, ultimately, for a brand's entire reputation. Getting it right avoids millions in losses, protects consumers. These stories, they aren't just warnings, are they? They're hard-won lessons for the whole industry, showing just how vital that diligence is.
Precisely. I think the common thread through all these cases we've talked about is that thoroughness, transparency, and just a relentless commitment to detail at every single stage, from the first design sketch, choosing materials, all the way to the final finish, the graphics. It's absolutely non-negotiable in apparel. It really has to be about proactive prevention, right? Through precise documentation, rigorous testing, not just reacting when something blows up. That's how brands build trust and how they keep it. One stitch, one spec, one test at a time.
And there you have it. From, Lululemon's see-through pants to Adidas misspelling Columbia to hidden chemicals in bras, all these different problems, but they all trace back to critical details, or the lack of them, in a tech pack. Hopefully this deep dive has given you maybe a new appreciation for the unsung hero of the apparel world, that really meticulous, comprehensive tech pack. So maybe the next time you pick up a piece of clothing, just consider that unseen journey it took. From an idea to your hands, how many tiny details, how many tests, how many sign-offs went into making sure it's safe and it works as expected. And maybe think, what other industries rely on this kind of critical but often invisible documentation to keep us safe with the products we use every day? We're curious. What stands out to you from today's deep dive?